Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. This time we would like to discuss the kinetic theory of case part 3. In this meeting we would like to learn about collision frequency, collision rate and mean free path. As you know that gas in the container is always move. In the movement, they collide each other. In the collision, resulting in gas pressure and momentum, as we learned in the first meeting. This time, you know, that two of the molecules, for example, just imagine, they just move and they collide each other. And you know, in the previous meeting, we see the collision is elastic. This meeting, we would like to discuss what is the frequency of collision and also calculating the rate of the collision. And then between the collision, the molecule just free from the collision. So meaning that molecule doesn't have to collide all the time. So the distance that they don't collide, then we call it free path. Because the distance is not always the same, then mean free path. Meaning that path that the molecule doesn't collide. Next, we learn about the collision amongst the molecules. Collision of the molecules can happen when the centers of two molecules have the distance d. Okay. Now imagine, to calculate the frequency of the molecules, the frequency of collision of the molecules, then we have to assume that in the container itself, only one molecule move, the other just stay on the spot, doesn't move. It is not right, but we just assuming that in the container only one molecule move, the other just stay. Let's go to calculate the frequency of the collision between molecules. I show you in the whiteboard. Here, as I mentioned, that the surface area of the molecules, see, the surface is D over here. And two molecules, let's say here I show you these two molecules. And the radius of one molecule is R, when the distance of the molecules is D, equal to the radius of the container, then can be warranted. I can say that the molecule must collide. This just quite true. Now you imagine that the surface area, here is equal to, as you know, P d squared. Okay? And you know, then let's say this can be represented by this. And you know, the length of the container is equal to v dt. Here is actually velocity or speed. and we can represent this by L. So now the volume of the container is equal to surface area time to the length, or equal to this. Can be written by P, D, and this V. Okay, this V, the volume. And you know that the number of the molecules in the container, let's say represented by N, and now the number of collision is equal to N per V. N is actually number of the molecule. This is molecule density time the volume, or can be written by B D square times V delta T. So then let's go to the next slide over there. So you that, you know, the collision of frequency, as I mentioned, you know, the volume itself equal to PD times V. Okay, and here is V average. No, V average. And how come then you get the root of 2? I can show you later on. As I mentioned earlier, that we only, okay, assume one molecule just move, the other just stay, doesn't move, don't move. And you know exactly that all the molecules just move. So now we go to the discussion. If the molecule, all the molecules just move, let's go to whiteboard. I can show you here. So you know that V is equal to PD square V average, meaning that V equal to P, sorry, this is V average. And as you know that when we here, if we discuss on the V average, that meaning this equal to okay, because only we assume that only one molecule move, then that's why this is only one molecule M. What happens if we have more than one molecule? So this should be relative, M relative, and this one also V relative. And you know that V relative here is equal to RT per P, and here we have M is mu. And what is the value of mu? Mu itself is actually MA plus MB. So V relative is equal to T P, and here is M A plus M P. Let's go here. V relative is equal to P time per, let's say, M1 plus per MP. So equal to RT per P. Let's say we make it here M A M B. So here is MP plus MA. If MA is the same as MB, so we have the equation that V relative is equal to RT per P. Okay, here is 2 MA per MA squared. We can just cross over there. So from here, then we have V relative is equal to 2 per half times V. Okay, so you can now understand why V relative is equal to the root of 2 times V average. Let's go back to the presentation. So we get now the V relative and V average. What is the frequency of collision? The frequency of the collision can be calculated by by multiplying the V that we have already carried times the density of the molecules, and I divided by N with the star. So we have collision frequency of Z1 here equal to the V times N star, and we get it like, you can show it on the presentation. I think everyone already understand how we calculate the frequency of collision between molecules. Just remember that here we only have one molecule just moving. Okay, so that's why the frequency of the molecule here is represented by the equation that I show you. Z1 equal to, you can see it on the presentation.